Section 1.5 is segments and their measures. So first we're going to talk about how to read a ruler in centimeters, inches, and millimeters. So first let's talk about inches. If you look in this top left-hand corner, we have fourths. So the first longest line is 1/4, then we have 2/4, 3/4, and 4/4, which is 1. If you look down in the bottom left-hand corner, if we go one line smaller, now we have eighths because there are 8 lines. So 1/8, 2/8, which is the same as 1/4, 3/8, 4/8, which is the same as 1/2, 5/8, 6/8, which is the same as 3/4, 7/8, and 1 inch. And if you look to the right, if we count every single line, we now have sixteenths. So 1/16, 2/16, which is the same as 1/8, 3/16, 4/16, which is the same as 1/4. So you'll notice that they're the same. So centimeters look like this, and centimeters go by tenths. So we have here, if we're measuring this line, we have exactly 7.0 centimeters. Now for measuring in millimeters, we want to move the decimal spot to the right once. So this will be 70 millimeters. So now we're going to measure in inches. Okay, so we have 4, and then we want to count how many lines this is. So that's the smallest line. So this is 1/16, 2/16, 3/16, 4/16, 5, 6, 7, 8, 9/16. So this is 4 and 9/16 inches. Now let's say our line only went up to, here. Okay, now we have 3 and 1/4, 2/4, 3/4. So that would be 3 and 3/4 inches. And let me give you one more example. Let's say our line went up to here. This would be 2 and 1/8, 2/8, 3/8, 4/8, 5/8. This would be 2 and 5/8 inches. So distance between points, the distance between points A and B is written as AB. So notice we don't put the segment bar over the top. AB is also called the length of AB. So length and distance are represented by 2 capital letters with no segment bars over the top. So the length of EF in this example is 7. And the length of segment JK is 13. So this brings us to the segment addition postulate, which says that if B is between A and C, then we know that the whole segment AC equals the first part AB plus the second part BC. Okay, the next statement says that if I know that to be true, so if AB plus BC equals the whole segment AC, then we know that B is between A and C. Dimension bars, this is just notation. The distance between 2 points or length of segments are also shown using dimension bars. this is how we show, hey, we're talking about this whole segment here. So from M to N, the length is 16. So we say MN equals 16. So use the map to find the distance from Athens to Albany. So that's point A to point B. So I'm going to use dimension bars. We want to find from point A to point B. So from A to M is 80 miles. And from M to B is 90 miles. So we're going to add those together, and that gives us 170 total miles from Athens to Albany. Find MO. So I want to know the distance from M to O. So that's going to be 5 plus 2, which is 7. So MO is 7. The length of MO is 7. So here's two more examples. Find AC. From A to C is 14 plus 6. So AC is 20. Find EG. So we want to find the length of EG. So 2 plus 5 is 7. So the length of EG is 7. Now, what if they give me the whole length of the segment? So what if they give me from D to F, and we want to find the length of EF? So we want to find from E to F. Okay, so this is where the whole length equals DE, so one part, plus the other part, EF. So we're going to subtract 10 from both sides, so 6 equals the length of EF. So now you can always check, if EF is 6, 10 plus 6 should give us a total 16, and it does. So here we know the total 9 from R to T equals the first part, which is RS, so that's 6, plus the second part, which is ST. So we're going to subtract 6 from both sides, and that means 3 equals the length of ST. Okay, so you can always check. 6 plus 3 gives me a total 9. So here for the next one, the total length from E to G is 23. So that equals the first part, 15, plus the second part, EF, which is what we're trying to find. So we're going to subtract 15 from both sides, and we get 8 equals the length of EF. We're going to introduce in some variables now. So here you could have done 23 minus 15, but now we have some variables. So we're going to have to set up an equation just like we did. So the whole length, 5x minus 4, equals the first part, x plus 2, plus our missing part, DE. Right? From D to E is what we're trying to find. So plus DE. And now we want to solve our equation for DE. We want to isolate DE. So we're going to subtract x from both sides, and we're going to subtract 2 from both sides. So 5x minus x is 4x. Negative 4 minus 2 is negative 6. And that equals DE. So DE is 4x minus 6. Okay. So if we were to add them together just to check our answer, 4x plus x gives me 5x, and negative 6 plus 2 gives me negative 4. So my parts, DE and EF, add up to give me my total DF, the total length of segment DF. So again, use the diagram to find AC. So I want the total length from A to C, which means that I have to add the first part, AB, to the second part, BC, and that's going to give me the total length of AC. So we're going to combine like terms. 5x plus 3x gives me 8x, plus 4 equals AC. The last part we're going to talk about today is congruency. In geometry, when segments have the same length, they are congruent segments. So this is called a tick mark, and the tick marks indicate that the segments are congruent. So here, segment AB is congruent to segment CD because the tick marks show that they're congruent. So this means that their lengths are the same. So this is very important. When we talk about length, we say that the length of AB is equal to CD. When we talk about lengths, we talk about lengths being equal. So we say AB is equal to CD. When we talk about congruency, we talk about the actual segments being congruent. So segment AB is congruent to segment CD. And this is the symbol for congruency. So you can see we say segment AB is congruent to segment CD, whereas length AB is equal to the length of CD. So determine which segments in the coordinate plane are congruent. So we want to know the lengths of the segments to see if they're congruent. So segment CD is 1, 2, 3, 4 units long. So I'm just going to put a 4 here. Segment EF is 1, 2, 3, 4 units long. Segment AB is 1, 2, 3 units long. So that means that segment CD and segment EF are congruent because their lengths are equal. So we know that CD equals EF. Their lengths are equal because 4 equals 4. And then we can say that segment CD is congruent to segment EF. And that's what they were asking. Determine which segments in the coordinate plane are congruent.